Okay, so now we move on to squaring our deviations. So the standard deviation square of rows will be this value squared, all these values here, and so that gives us these figures here. Then for Thorn, it will be the same thing. So we square all these values, so which is the standard deviations for each year. We square them and put them in another column. Then in our final column, we are going to multiply the standard deviations of each company by each other. So it will be the standard deviation of Rose times the standard deviation of Thorn. So that gives us these values here. So we multiply them all together and add them all up. Now we need to move on to finding the standard deviations of each of the companies. So we add up the square over here of the standard deviations and get the total. So that will be 160 divided by the number of years. That gives you 32. So then 32 gives you the mean, but then the square root of the mean gives you the standard deviation. So you need to find the square root of 32, and that will give you 5.66, which will be the standard deviation of Rose. Then you do the same. So you add up the squares of the standard deviations of Thorn, and then divide by the number of years, and that gives you 16.96. You square root it, and that gives you the 4.11, which we have here. After calculating these standard deviations, the question requires you to find the coefficient of correlation, but in order to find that, you need to get the covariance. So our last column, you sum everything up, and then you divide by number of years, so that gives you 16. Now to find the coefficient of correlation, it is the covariance divided by the product of the two standard deviations. So it will be 16 divided by, then into brackets, 5.66, which is the standard deviation of Rose, times the standard deviation of Thorn, and that gives you a value of 0.6868. So that would be your coefficient of correlation between the return of Rose and Thorn. In the exam, you could have her ask you for the co-movement. Co-movement is the same as coefficient of correlation, so don't get confused. Now we go back to A, and then A, it says we need to find them to the nearest percentage.